Okay, so I'm from the New York Hall of Science in New York City, and what I'd like to talk about is how we developed a social interface to study Enaction in museum settings, and the particular platform we've developed is related to how people understand sustainability and resilience in the coupling of human and natural systems. So by the end of the talk, I hope I'll have made clear that the notion of Enaction is important to science museums, that Enaction provides a useful understanding of learning and how it differs from traditional approaches, and the design example, which I'll talk about, which is called Connected Worlds at the New York Hall of Science, about the coupling of human and natural systems, and our efforts to trace learning through time and space using this platform and other platforms, digital platforms. So at first, I just want to differentiate Enaction from the most widely accepted model of cognition, which is called the computational representational model for understanding the mind, also known as CRUM. That's probably it's a worse acronym than I could even come up with. And it posits that the mind is essentially a computational organ that processes with processes that operate on representations of the world through algorithms. So Enaction, on the other hand, posits that CRUM is at the very least, an incomplete explanation of the mind, and at best, I would argue, is actually a barrier to understanding the human capacity for learning and developing useful metrics for analyzing learning in complex dynamic systems, which is my goal. The definition for Enaction that I'm using here, and there are multiple ones, is the one proposed by Varela, Thompson, and Roche, in which, in their own words, consists of perceptually guided action and cognitive structures emergent from the recurrent sensory motor patterns that enable action to be perceptually guided. Important to the notion is that mind and body are unified, and there's a structural coupling to the environment that has to be considered when we think about learning. Interest in the application of Enaction as an epistemology rose rapidly through the work of Seymour Papert, who developed it with his colleagues an AI programming environment called Logo for children, which was originally based on Lisp, which was commonly used at the time. That goes back as early as the late 60s, and it's still, Logo is still commonly used in teaching and learning. But this idea that he came up with this idea called body syntonic reasoning, in which the subject would transfer the proprioception of an object. In this case, they were called turtles for no particular reason, but that was something that they could center around. And it could either be represented as a cursor on the screen or as a physical object in space. And they coined the term constructionism, which combines constructivism from the Piagetian perspective with actual doing that can be measured through understanding how children actually respond to and actually use Logo. I believe science museums are particularly well suited to explore Enaction because there's an emphasis on providing participatory ways to learn, and that means learners engage in doing and understanding something better than just thinking about it, reading about it, or being told about it. So there's very little lecturing going on in science museums. There's, at least our science museum, there's very little courses that are given that have grades at the end. It's really about free choice learning. And free choice learning, because it's not compulsory, they can come and go as they please, is basically could be categorized as people living their lives. So Falk and Dierking famously called this a 95%. 95% of your life is spent outside of formal learning, and part of that time is spent in science museums and other cultural institutions. So it serves a very important role, and also a role as a laboratory for studying this kind of learning. For me, I'm very interested in the idea that looking for a kind of unified field theory for learning that seeks to understand and unite how thinking and learning happens in social, material, and natural environments in which this kind of learning happens. So to get a more nuanced understanding of the role of Enaction in learning, there are some recent innovations in the study of the brain that I just want to go through that might be useful. Up until fairly recently, we thought about the brain the way Paul Roca and Franz Gall did back in the 1800s. that we could map areas of the brain that did things, and then we could think about how to break those pieces into smaller and smaller areas with more and more refined sort of tasks, thoughts, or functions. And we model learning environments in a pretty similar way. The industrial model of learning, which comprises much of formal education, also believes that you can break up learning into little pieces and then stick them in those little areas of the brain to think about those things, and that they'll somehow magically stay there. But neither of those ideas were very good models for the way learning or thinking works. Both learning and the brain were essentially black boxes, and a lot of this was conjecture. But it also made it logical to think about the brain as a computer, since that's what computers do. They do certain things, they store things in certain places, and then you go dredge it up from that place and do something with it and then put it back. But by the end of the 20th century, and with the aid of increasingly powerful techniques to figure out how the little blobs on the MRI images actually connect to each other and the rest of the world, we could start to unravel the mystery of how very complex systems of the brain work, which are more like the internet or a network of networks than a single computer. But it was only possible to get a peek under the hood of all this and how it relates to the rest of the world by looking at the connections in this network of networks. The Human Connectome Project, which took place during the early aughts, I guess it started around 2004 and is continuing, has revealed that the brain is way more complicated than anyone ever dreamed, and that if you really want to understand it, you have to think of not just how the structural connections work in the brain, but also how the functional networks develop in the brain. And these functional networks are largely invisible in terms of looking at neuron connections. They're only visible in terms of how they actually work and when they're actually working. So what the connectome does is identify both the functional and structural pathways and try to account for the ways that neurological responses propagate within and among brain networks. It also helps undo the crumb model of the mind by deepening our understanding of how brain networks connect to the environment. So there are three large-scale networks in the brain that are helpful in thinking about this. Wow, it really looks fluorescent, doesn't it? There's something called the default mode network, which is on all the time. So unlike a computer, we don't ever shut off. Even when we're under sedation or asleep, we're connected to the environment. Obviously, if the cave bear is coming after you and you're asleep and you hear it growl or something, or you hear it trip over something, you can get up and run away. That's obviously a survival mechanism. Default mode the central executive network is the network that's active when we're doing things, thinking about things, when we're active and conscious and we're paying attention to something. There's something called the default mode network, or the salience network, I'm sorry, that actually does the switching between those two things. And that was something that was discovered fairly recently by Menon and Uden, and it's been implicated in a dynamic transition from default mode to central executive. So when we transition from paying attention to something and engaging in something from not paying attention to something, that's the switch that goes between the two. And these are very large-scale, complicated networks, and you can see the areas of the brain that are implicated in those networks. So while connectomics is helping to put together a puzzle of large-scale brain networks, their role in participating in the environment to some degree, it still presents an incomplete picture of the mind. So Gregory Bateson posited that learning is an iterative structural modeling of evolutionary processes in the interaction between mind and nature, a recursive process for seeking patterns that connect ideas and materials among thought, action, and interaction in our environment. Like nature, we try things out over and over again until they make us better adapted. He believed that everything is connected through patterns that have evolved throughout the history of the Earth, and that we embody the processes in learning. Something is very special about this idea of learning and evolution and the connection between them. And if we look at something called the ecological niche, it'll help us to sort that out. The most fundamental way living things extend their behavior into the environment is through the ecological niche. We all probably know at least to some degree how that works. That's adapting to a localized space in which an organism lives. It's different from the way they might adapt in a different localized space. So if an organism evolves within an area, an ecological niche where there are lots of trees, they'll learn to climb trees and exploit resources there and escape from predators. But the problem with this is it takes many adaptations through many mutations over many generations with many individuals in order for this to actually become adopted commonly as part of a species morphology or behavior. So the problem with humans is that we break this notion. Sometimes I call this evolution 2.0, because cognition happens in the environment through the ways we adapt our behavior to the local conditions by improving solutions to problems using aspects of the environment to improve survival. This has come to be theorized as the cognitive niche, as proposed originally in the 80s by Tooby, Kosmides, and DeVore, and was made popular by Steven Pinker much later in the late 90s and early aughts. It consists of a mechanism which makes use of contingent information for the regulation of improvised behavior that's successfully tailored to local conditions, essentially mimicking evolutionary processes through changing our behavior on the fly. Although this is now believed that humans are not the only species that do this, it's a matter of degrees, we can attribute the extreme level of sophistication of this in a single species, possibly to the unforgiving selective pressures on it. Humans traveled in very small groups and were subject to a lot of hardships, and the evolution of language I'll get into a little bit more. But at its essence, while the cognitive niche allows us to more flexibly adapt to the environment, in the ecological niche, it's not a free-for-all. We have to regulate our behavior either psychologically or socially toward improving our survival. Without such regulation, an intimate coupling of internal functions with external survival tactics, making choices could lead to catastrophic errors. Meaning you have to be able to imagine with some accuracy what will happen if you do something and whether it will result in disaster. Everyone's familiar with the Darwin Awards, I think based on that notion. But it turns out there are some networks in the brain that actually assess risk and then actually decide whether to do something risky in it. And they're between the subnetworks that affect exploitative behaviors, which is found in the striatum and ventromedial prefrontal cortex, and the exploratory behaviors, which is in the frontopolar cortex and interparietal sulcus. So there's this tension between these two networks, and they actually interplay with one another to make these kinds of decisions, and ultimately whether they're good or bad decisions governs our fate. So through the marriage of the terms cognitive and niche, we're intentionally uniting the mind with the environment, which is the basis of the theories of Enaction, in which the mind is quite literally extended to the environment and embodied in our interaction with things. So the way Andy Clark puts it, it's becoming clear that human mind shapes and in turn is shaped by how we design, create, modify, and interact with our physical environment. It's argued by Iriki and Taoka that the intersection of the cognitive niche and embodied cognition is a theory of niche construction, which is widely argued back and forth by different theorists, which is the interaction of ecological, neural, and cognitive systems through a kind of positive feedback loop. So we actually create the environment in which we adapt. So the idea of intelligence is not just about how we think, how we learn, and the knowledge, and how this evolves in this niche, but how we evolve the thinking, knowledge, and learning within and among the material and social culture we create and engage in. Niche construction is likely how we managed to use the same brain 50,000 years ago to beat back cave bear attacks and chip stone tools as we do now to design computers and build jetliners. But we know that it takes more than one person to build a jetliner, so the cognitive niche also applies to social interactions to the extent that it allows us to engage in coordinated action. So the way Pinker put this, it's like fanning out over a landscape to drive and concentrate game, or to collaborate and cooperate in designing and building a computer or a jetliner, functioning more like a superorganism, which we know ants have been doing for millions of years. Significant role of the social interaction in the cognitive niche, as the Witten and Erdahl, they call it the socio-cognitive niche, sharing the cognitive load or intellectual burden, assessment of risk, etc., increasing the chances of survival, and a kind of crowdsourcing of decisions. Another conclusion that can be drawn about the cognitive niche is that thinking, communication, and doing are part of the same process. The importance of language and the social dimension of evolution of culture can't be overestimated. Umini and Meyer were a couple of archaeologists that compared response centers in the brain for language and for doing. In this case, it was chipping stone tools but they found that the same part of the brain and the same formation the same centers in the brain, same center in the brain for doing is also the same center that's used for language. So the idea is that the implication for this is that language and doing, whether it's chipping stone tools or whatever it is, evolve together. And it's conjectured that this could go back as far as 1.75 million years, which would mean it's a shared characteristic with Homo habilis. So it can be theorized that social interaction and language are essential to the evolution of human evolution, how culture is generated. If we were not intensely social and complex and social beings with complex language, those were not part of our repertoire of behavior, we may have never become human and might even be extinct. The neurophysiology of cognition includes the ecosystem of interacting organisms, something Luhmann actually has described as an autopoietic system in and of itself. So if we propose this as a general purpose process for human social systems to manipulate the environment and develop what we now call culture, while culture is ubiquitous in nature, what makes human culture unique is the degree to which we leverage cognitive niche and our social interactions, use language and share complex ideas, and record this culture, and continue to tinker and enhance over time. Thus, for cognition in humans to work, it must be centered on the network of interactions among adaptive, neurological, social, physical, ecological, technological processes going on around us. I'm going to rush through some of this stuff because I know we're low on time. So I just want to go back now to science museums, which we started with. While we've always embraced this idea of engaging through Enaction, network theory and its neuroscience is sort of helping to confirm that there's something fundamental to learning through doing. Pioneers of learning have sort of intuited this for many years. Piaget's constructivism, Levi Strauss's bricolage are examples. There's always been this idea that even Dewey, going back to Dewey, that we embody learning and that we learn better, or we learn some things we can't learn at all without using embodied learning. So that brings us to the project I'm working on. And again, my interest is in looking at complexity. How do we bring complexity to the public and give them tools to understand it better? I designed a platform that actually is intended to study embodied learning, and it's about the coupling of human and natural systems. So the idea is to have a platform that you can have large social groups. We can have up to 50 people at a time in this exhibit and solve problems in the coupling of human and natural systems. A lot of literature out there suggests that systems thinking is extremely important for understanding this kind of coupling and understanding complex natural systems that are dynamic. So we place an emphasis on that. And the problem is that presents a paradigmatic problem for lots of people because they're not taught system thinking anywhere. So where do they get, how do you take people from a very low barrier of entry and a lack of understanding of systems thinking and on-ramp them into doing some systems thinking in a fairly sophisticated way? I'm just showing this map here because this is actually a map that shows the human consumption, human appropriation of net primary productivity in the world. And you can obviously see where there are major metropolitan areas, they consume many, many more times than what they do in others. So here you might be consuming 40,000 times the available net primary productivity of the land, whereas there are places where you couldn't grow anything that's useful for people to eat, so it's not used. But people get very confused by looking at these kinds of images because they don't understand how the resources are allocated from one place to another. They think very simplistically in geopolitical terms. So we had the city was renovating a space. This is an 8,000 square foot gallery at the New York Hall of Science, designed by Wallace Harrison, and we were able to build an infrastructure to house this exhibit. So this is a sort of a view overhead, and it shows that we took an old idea called CAVE, which Tom DeFonte premiered at SIGGRAPH in 1992. The idea being that you create an immersive environment, physically immersive environment, and give people tools to actually explore it. So the decisions in terms of how to do this, we decided it had to be completely immersive. So we needed people to be really deeply in the experience. It needed to be a social space because we were very interested in how social systems evolve while they're interacting with natural systems or representations of them, and provide unencumbered interaction. We didn't want them to have to wear goggles or hold anything or have to wear anything. They were being tracked completely unencumbered. And then using naturalistic affordances. So human gestures are basically what are used to navigate and manipulate the area, the exhibit. And this experience is called Connected Worlds, and it's open now. I expect it to last another 10 years. It's currently the largest immersive interactive experience of its kind. Hopefully others will rush in and do more, because I think there needs to be a lot more investigation of the usefulness of this. It's a highly animated and responsive set of virtual spaces. It uses very fast gesture sensing and tracking systems, and groups of visitors can interact directly with CGI characters, and they respond to them. It opened to the public in 2015. This is the entire space shown. So the waterfall at the end there is about 40 feet high, and there are 3 different biomes represented. There's 4 different biomes. There's something like a wetland, something like a rainforest, something like plains, and something like desert. And we did a bunch of prototyping and found that when we tried to the more we tried to represent things as they would actually be in nature, the more people inserted their own sort of archetypes on them, and so couldn't really pay attention to the systems that they were intended to investigate. So we had to sort of start over. We did 4 large-scale prototypes, and after the second one, we realized we had to completely change our thinking, and which is why we came up with these odd, fanciful kinds of environments. You'll notice there are 3 sort of water sources. There's a river here, there's a reservoir, and then the waterfall itself. And this is actually a freely negotiable floodplain, and these are retroreflective logs that actually people can guide the water on the space to the different habitats. So they have to water them, they can chop or plant vegetation, and they can then we look at how the visitors respond to what they've done and the results of what they've done to these environments. And because they're all connected, there's the ability to have teams work together to solve problems and try to balance the needs of all the different environments. And this gives you a sense of the structure of it. So we have these inputs and outputs essentially, and this is sort of a free space where you can allocate the resources. There's some children dragging these retroreflective logs and moving them and guiding the water. This is the waterfall. So this shows a little bit of the sort of the gestures. You can see this person's actually releasing water from the reservoir by annoying a slug. It's over here. If you annoy these slugs, they move and they let the water out, and then you can use that water. So the idea is to give our visitors a sense of capacitance and delays, which is part of the system's ideas. And again, the idea of using this as an analytical tool to understand visitor interactions and learning. So we've outfitted the space to log all of these data and to aggregate it and look at the kinds of analytical tools we might be able to use to actually study this. So there's a tablet application that allows us to change what's going on in the different environments, and we can invoke a rainstorm or a flood or a drought, and we can preset them so that we can give it the degrees of these kinds of phenomena, extreme phenomena. The idea being that we want to look for pro-social and antisocial behavior. We have some game theorists working with us from Yale, and also we're doing a lot of our own research in salience in terms of thinking about what are the things that visitors are paying attention to and thinking about while they're doing this. We have a lot to do in terms of how to actually record and understand what's actually going on, because you have 40 people in the space, which is pretty much, that's the norm, and they're continually in conversation with one another. They're gathering in groups, they're strategizing, they're taking on roles, but monitoring all of that and somehow figuring out what's actually going on and then figuring out what the learning is really pretty daunting. So we're still working on getting the bugs out. But this allows us to look at some very gross changes in behaviors. So when we create a drought, for instance, we've actually had much more aggressive behaviors emerge in the space. And when there's plenty of water, cooperation is the norm. That's the default, and people take on roles willingly and everybody's happy. So I mean, those are just obvious things you look for, but we want to know a lot more about what's actually going on. Oh, and this is some of the logs stream out from all the different habitats and all the aspects of what's being projected and what the actual what things are being changed by the visitors. This is just a snapshot of the desert at a particular moment in time. We're doing 1 second granularity right now. I'm not sure if we need to do any more. We don't know yet. So again, this is fairly in its infancy. We pipe all this stuff up to the cloud, and then we analyze it offline. Along with this is a large-scale schematic of the entire space that we sample moment by moment, that we can compare to the tabular data that we're gathering. And this is the ugly reality of the tabular data. Just what it looks like when you bang it into an Excel spreadsheet. But it gives you a sense that there's all this going on. This is one session, which is about half an hour. And then, so we're looking at some analytical systems to try to unpack this. We have another embodied learning experience called OzTalk, which is actually a table where kids manipulate these blocks to create circuits. And we can actually look at proximity. We can look at we use clickstream data because it's actually an interface to a computer like you would have for a mouse, but it's multi-touch, so it's like a lot of people with mouses. And we're able to take the clickstream data and actually analyze it through a software package called Adage, which is developed out in University of Wisconsin. We've been working directly with them. So it records primarily streaming events, but the thing that's nice about Adage is it applies it the analytics in real time, so you can actually see what's going on. It works in Python, which makes it easy to use. So here's the 5 top most frequent kinds of events. This is in OzTalk again. That shows the distribution of time deltas between successive events. That's just using a kernel density estimate. Nothing terribly sophisticated. And this is just a bar chart of the types of events in the data, of how many of each kinds of data that are in the data set. And these data can be interrogated to see what happens in the vicinity of events. So there's XY coordinate data. So where people are at this table is also recorded. And that has resulted in our colleague Mike Tissenbaum from UW-Madison developing a companion tablet application where you can actually look at, you can see where things are happening. And the idea was to build in flags that if people are struggling, there are indicators that can be brought up. So a facilitator can use this to actually go in and say, do you need help? Or go in and make some suggestions, or just monitor where the trouble spots are to see where the problem is. And this is a really great analytical tool too, because you can monitor anything in real time and just sort of and log all this stuff, which is something we haven't been able to really do. But adapting Adage to Connected Worlds is a whole host of issues that we're still working on figuring out how to deal with. And that's the end of my talk. These are our partners, the Lamont Doherty Youth Institute, NYU Games for Learning Institute, Yale Cooperation Lab, Design.io did all the graphics and that stuff. And it sent me out of it. But I have to say, at least that NSF, where'd it go? Oops, cable came out. I have to say this. Thank you to NSF, because in my annual report it says, did you promote the use of NSF funds in your talks? Also, Google contributed a huge amount of money. JPB Foundation was amazing. and then Xylem, Carnegie, and actually NASDAQ contributed to this cause. So this is all very nascent, all very new. We don't have any idea what we're really doing, but what we're trying to do is find a way to build in analytics that can look at and really mine Enaction to get a sense of what embodied learning is really about, and how we can start to pull that away out of the dock of the way that learning sciences are now, which is based on classroom learning primarily, and really start to build a distinct way of understanding embodied learning. That's
Thank you for a great talk, and thank you for showing us things you do, so we can actually see, how ideas that we have could possibly, change the patterns that you are seeing. I have just a question. Do you tell people coming in what you are interested in? Because you're not really studying the ecosystems, you're studying the way that people learn, enacting their understanding of the ecosystem. So you're looking at the relationship, but you're also looking at the relationship of you as a designer of these learning spaces with these people. And do you tell them that you're doing that?
So we have an IRB that we have to answer to, and when we're doing surveys or we're monitoring or observing children, particularly, we have to report that.
Oh, no. I mean, so you tell the people who are coming in what you are interested in?
Not specifically, because what we want to get from them is whether they're actually learning from the experience itself. We have facilitators that talk about what the learning goals are, but we don't actually tell them that we're doing large-scale experiments on big data about this experience, and looking for certain kinds of ways that people understand their relationship to these natural functions that they're engaging with. So the answer is no. We don't tell them explicitly that we're researching this, particularly if we're using log data, because it's completely anonymized. They don't have to know. But when we do anything that's intrusive, we have to report that.
Just to add quickly why I'm saying this, I think that if you are letting them learn about something, they think they're learning about something predefined, while actually it's much more exciting than that.
Well, so we orient them toward the goal of the exhibit, which is to understand how human systems and natural systems couple. When we tell them that, it's, we have audiences from business executives down to toddlers. So if they can, even if they just crawl, and push the logs around with their heads, we still invite them into the experience, and we try to. They tend to come in groups very often. They're school groups, so their age. There's some homogeneity in the age group for the sake of studying, but we don't exclude anybody because of age or particularly pay attention more to one age than another. I think I think this is kind of the first stab at the problem, and we found that I showed you that human appropriated net primary production map of the world. I've used that in teacher training and other kinds of sort of remote sensing. That's a mixture of remote sensing and economic data, but they don't have any idea what remote sensing data is, or they don't even know what infrared is. Never mind how different types of vegetation are detected and understood, and sea level, height. I mean, it's just not part of their reality. So finding ways into teaching, because we do a lot of teacher training too, is something we're very interested in. The systems idea is really elusive to people, and they say they know what it is, but they don't know what it is. Yes, I'm sorry.
Exactly, that's my point. Look, have you tested whether it's actually important? What if you took a group such as this and put them in? Would we behave any differently?
That's a really good question. So when can we do this?
Next year. This weekend.
What's the name of your museum and where is it?
It's the New York Hall of Science, and it's in New York City. It's actually in Queens, so it's about 5 minutes from LaGuardia Airport. We're conveniently located that way. And anybody here is invited. And again, I think one of the things I want to try to make clear is I think science museums in general, but ours specifically, are opportunities for studying Enaction and cybernetics ideas with real people in ways that could inform the field in sort of a direction that will help instruction specifically. Because I want teachers to think this way, not just sort of a group like us. And I think that until we get to that point, teaching and learning is going to be a pretty barren enterprise, and we're going to keep cranking out people that elect Trump. Sorry, I had to say that. Yes.
One of the most effective exhibits I saw was at COSI in Columbus, Ohio.
We work with them a lot.
Yeah. Well, it was a bicycle apparatus that had square wheels, and it ran on a corrugated concrete track. And it was very suboptimal, and people got a chance to pedal and see how hard it was. Is there a place for suboptimal solutions and even failures? Herbert Brun always wondered where the failures were in science museums.
Okay, so this in particular and other experiences, we've taken a new direction over the past 10 years. No, I'd say 5 years. Instead of the sort of one-off, here's a science concept, it's very content-oriented, and try to give you some insight into a content piece. To look at really how to build open-ended enterprises that students can engage, kids can engage in, and have their own entry point, their own sort of value system about what they want to achieve, their own goals, and basically have a set of tools for them to achieve those things, and opportunities to fail. We have an entire 7,000 square foot exhibition called Design Lab, which is intended for kids to try things out and fail and repeat trying things out. And we rotate a lot of different kinds of activities in there. Everything from sort of architectural kinds of things to building circuits. But there are a lot of different kinds of activities, and they're specifically intended to be open-ended and allow not even call out failure, but look at iterative design as a process for discovery. We also have a makerspace, which has lots of opportunities for that, because people dealing directly, intimately with materials and tools is a whole other piece of that, even though Design Lab is designed for more sort of formalistic, here are the things you can use, do something with it. With Makerspace, they're very specific. There are laser cutters, there are 3D printers, the kinds of tools you would do to create something, to actually apply toward developing an idea. But they both actually are very informative, and we do a lot of work with learning researchers in both spaces to figure out how kids are iteratively working with these tools, and what happens when you give them a very low barrier of entry and sort of very high intellectual ceiling, and how do they negotiate that? And that's a very strong interest of ours. We do a lot of work with Indiana universities, at School of Education, monitoring these things, logging them, analyzing. So we have lots of interest in that and partners we work with.
Thank you.
There's a square rail bicycle at the Math Museum in Manhattan also, by the way.
Yeah, I helped them start that museum, and we tested their bicycle thing, and our kids broke it. So,
my question is, as you, I'm curious, as you presented the kind of viewpoints in the museum that are saying there's an embedded participant point of view, and there's a ubiquitous big data point of view, and of course I understand that you need to have that to actually write the code, but I'm wondering whether as runners of the museum, whether you spend all of your time in the big data view, or whether you move back in, like the programmers and so on, whether they move back and forth between the participants, the embedded view of what experiencing the museum and looking at the analytics, or whether there's a big separation.
Well, at the sort of level of personnel-wise, it's kind of a balance of both, because to be perfectly crude about it, where the money is in big data. So I will go for grants that emphasize that, and they require a certain amount of time spent dealing with that. And so that becomes sort of my thing. I spend very little time, I'm ashamed to admit, on the museum floor with the kids. I used to, and I regret not being able to do that anymore, but I've got my head down in data these days, and that's what funders want to see. So does that help?
Yes, that's, but the people actually doing the programming work will probably go back and forth, or is it really?
Oh yeah,
really-
well, it's mostly grad students, but
Yeah.
you know the people that actually create the applications and do the analytics. But yeah, we usually have grad students actually give the surveys, or actually do the observation, or gather the data and clean it, and then we actually sort of take it and begin to deal with the issues around it.
And do you think it would be do you think it would be possible to design a system that was completely embedded, that was managed completely from embedded?
That's the idea. We're actually looking at some other tracking systems that we can identify individuals, and it's surprisingly hard to do well and scale. You know, so you can do it with a few individuals. When you have 40 people running back and forth, it breaks it pretty quickly. And we went through everything from LiDAR to ultra wideband to RFID tags used in industry and those kinds of things, and we couldn't get the speed and accuracy that we needed to actually do this thing. So it's a compromise.
Thank you.
I keep thinking that if your goal is learning, and if your goal is learning on various levels, what would you think is the most important? Would you just let people experience being, dealing with this kind of environment, or do you think that learning requires a more conscious ability to reflect on what they've just learned?
Yeah, so we're very interested in reflective activities, narrative building.
No. I mean, after I go through this experience, say with a group of people, do I then just go out and say bye-bye, we'll go back to usual? Or do I get a chance to actually look at the analytics of my behavior and say, whoa, I really did not do very well in communication or group formation? Because I think it's that consciousness that would seriously change behavior consciously.
Yeah, so one of our hopes is that we're interested in this idea of a third space, which would be a place where it's not the classroom in a formal learning environment, but it's not an exhibit space, but it's a place where people where it's sort of a hybrid, where you can reflect on what's been going on, and in terms of the interchange between the visitor and the scientists and teaching and learning professionals, and sort of build out these ideas of everything from storytelling to, look at what happened and what do you think of it, and how do we think about sort of more sophisticated ideas out of this. We're not there yet. It's a surprisingly difficult thing to do, because you have to get all of these different entities in the same place at the same time and have them have sort of this rough overall goal. And getting the visitor to actually spend some time doing that is something that we found is very difficult unless you give them at least $20.
Well, you said you work together with educators, and I think especially in that case, that's precisely what they're doing.
Right, well that's, again, my goal is that the things that we do and we do well and where we know learning is happening, that we find ways to transfer those skills to teachers. We do a lot of teacher training. I run teachers pre-service learning programs and in-service learning programs. We have a lot of involvement with teachers. Getting them to think outside of the reductive box and having the time to actually do that is a challenge. And we run workshops specifically on things like complex networks and systems thinking and those kinds of things. And again, one of the challenges we've run into is they're very good at spitting back to you what you told them. in ways that you think they know what you said, what you think they understand. But when you actually test them in sort of in a more sort of like, abstract environment from the actual, like, normal sort of lecture kind of thing, they're completely broken. They have no idea what they're doing. And it's because they're very well crafted at giving you the answer that they think you want, not giving you some indication that they understand what you're talking about. So we've had to rethink how we train teachers very deeply, because a lot of teachers don't get it, and we have to find new ways to get them to understand these ideas, which are completely counter to the way they were trained and the way that they practice. It's a surprisingly hard thing to do, and we've done a lot of it.
There's a very powerful exhibit on resilience in the Science Museum in Shanghai, which is their butterfly house. It's an overheated, dusty, very crowded enclosure that has thousands and thousands of dead butterflies and a handful of dying butterflies. And it's an extremely powerful exhibit on resilience. Unintendedly so, but very powerfully so. So I think that goes into the direction of what I believe Alena was actually alluding to, the question of, can that ecosystem that is simulated in your space, can that actually fail and desert, and that's it? Is there a potential for catastrophe? That is one part of the question. Another part of the question, us having also designed museum exhibits before, one of the things that we've learned is that museum exhibits as artifacts have a need for resilience in the sense of vandalism-proofness. So objects that are presented to a museum audience have to be resilient in the way that ATM machines and bulldozers are resilient. And how can a class of media like that be used to demonstrate the resilience of a butterfly is, I think, a really interesting question. Is that something you think about? Because I'm getting the impression that you're generally optimistic and positive about the role of technology in this kind of education.
Well, I'm not. I guess optimistic would be a slight mischaracterization. We have to rely on certain tools because we can't watch everybody at once, and those tools have their own biases. Even a video camera. You think, well, a video camera is a point of view, and you have to interpret, or the grad student or whoever is doing the work has to interpret what's going on in some way. And you're as Bateson says, we see the world through patterns that connect, and those patterns can have something to do with something, or maybe they don't. There might just be a pattern. But as far as the experience, I showed you that interface that you can change the settings on. One of the things we do is we invoke droughts and floods and rainstorms, and we made a cognizant decision not to have things die in the conventional sense of, like, the rat was laying on its back with little crosses for eyes.
Which unfortunately is a part of resilience.
Right, but there was a decision early on about we don't want to take the Al Gore route of saying, here are all the terrible, dire things that are happening in the world, and you can't really do anything about them, so we just want to let you know, as opposed to figuring out some way to engage people in a much more joyful activity that they can actually accomplish things in. And yeah, you could say, well, it's biased toward that, but we didn't want to basically shut people out by giving them the sense that they had this sort of helplessness. The agency that the individuals have in this is very high, and they feel very empowered through that. So we want to leverage that and understand what the impact is on their thinking. And ideally, of course, we're way far away from this, but can they generalize that out into the world? Can they go back into their communities and think about that?
Would you be interested in trying to have this environment desert and just let it
We can do that.
turn into something desperately barren for a month and monitor
Oh, I see what you're saying,
what
yes.
people will attempt to revive it?
So, an administrative decision was made to have sessions. Originally, the idea was we set it, we forget it. Whatever the condition is that people encounter, they come in and out. whatever the condition is, they have to cope with it. And obviously through facilitation, they can be helped to understand, okay, so everything's dead. What do we need to do to bring things back? Where's the water? Find the water, figure out how to distribute it. Let's try to bring some life into these deserted environments. Or conversely, everything's completely flooded, everything's rotted. How do we deal with this? How do we get water out of these systems and or move water to different locations? I mean, there is built into the system that capacity, and it can run on its own without end. It's just that because of the way that the museum, the experience, we get 2,000 visitors in a day. We can't cope with more than 40. To have any quality of experience, more than 40 people at a time in the space.
And last question: when you make those curatorial decisions and choices,
I don't make them. I want to do it differently.
Okay, not you personally. When the museum makes those choices that result in biases, you said some of these biases might be technical, some of these biases might be curatorially, and some of these biases might have to do with your relationships to funding sources.
Oh, absolutely.
How does the degree of joyfulness or barrenness of your environment depend on the image that is projected towards funding sources?
They knew that was coming. We have a very close relationship with our funders, and we invite them in, and they're the people that are responsible for those things to actually. We create these disasters for them to deal with as well. So I mean, they know, they understand what's going on in this exhibit, what our goals are. But that doesn't change the reality that funders fund certain things. So what you're showing off to NASDAQ is going to be different from Carnegie Corporation or Google. We have Googlers come in and use this exhibit. We have people from National Science Foundation come in and use the exhibit. They like to show it to Congress to show you can do amazing things with what they call, I hate this, cyber learning. They call it, talk about something that denigrates the profession, but and they're the only ones that call it that. So, and that program is gone. So hopefully cyber learning, the term, will die an untimely death. I'm sorry?
What do they mean by cyber?
They mean learning that's enhanced through the use of computers. This is the National Science Foundation, their term they came up with. We got trouble.
Yeah.
What do people want to fund? What do different groups want to fund?
Oh, well, big data, data mining, machine learning, sort of these sort of new ideas in computation to a large degree. They want to fund social, things like smart cities initiatives, funding underrepresented groups to get involved in sort of vocational kinds of things. We actually have a program. It's called Big Data for Little Kids. We have 5 to 8-year-olds learning data literacy skills. That's funded by National Science Foundation. I love the National Science Foundation. I love them. And they do amazing things, and we get amazing support from them, and we're extremely grateful. We'd like to have a little more input on some of those things, that's all. Are you going to erase the part about cyber learning? I hope so.
You wish.
Actually, it's done with, so.
I can do whatever you like.
Okay, I know we're out of time.
I have a question.
Yes.
So you said that the visitors can't be induced or evoked to give you back the kind of feedback you want, shy of giving them about a $20 reward.
Well, in a formalized environment. So we were talking about if you want to, after this experience, you want to sit them down, take them into a room, and do a deep dive in what the learning is, show them what's going on, what they did, what they didn't do, and then give them opportunities to sort of scaffold their understanding. That's something we haven't been able to do without a lot of people want to move on. They want to do something else. They want to go to the zoo. They want to go to the botanical garden.
Have you given any consideration to any kind of an app that they could interact with you the next day, the next week, so that on the way out you had a nice QR code that said, want to learn more? Want to talk to us about this next week? Scan this?
Yeah, we have some additional money, and we're doing that. We're not there yet. And the idea is we would, on our server in the cloud, we would actually give them access to those data in some format that's, human usable. And they would be able to follow up with that. And we're also working on a tablet application that's sort of inspired by this. It's not exactly like it.
Yeah, I'm just thinking that they all have phones. If you catch them with something on their way out the door where all they have to do is scan a QR code or take a picture, you may get them without having to give them $20.
Right, and we found that for some groups that works really well, and others they just never go back. So it's always a mixed bag, and I think to the point of like having some kind of formal way of thinking about how to scaffold this third space idea is something we haven't really gotten off the ground yet, because getting buy-in requires that there be some kind of incentive, and we haven't figured out what that incentive is yet. Giving people course credits for their master's degree is not enough.
Have you considered cupcakes?
We do, so with this Big Data for Little Kids program, we serve them pizza, and they come every single time. Some of them probably just come to eat, but it's amazing what you can do with a pizza.
Maybe in that vein, I think you could even be more simple. You don't need to put a pizza there, because most people are interested in how did I do, how did we do, and the easiest way to do this is usually by a visual representation. There's so many visual graphics coming out of, for example, how did I do in this run of this computer game? And it's an immediate feedback, and you can actually make this a packaging of the data, for example, of that session,
Right.
that particular group. How did we do over there? Did we organize our group or not?
We actually, this tablet application we're working on will do that, but we haven't done that for the big, large-scale application. Again, we're doing some iteration of that as sort of some follow-on funding, but we haven't gotten to that yet.
One of the things that happens with the Vester Echo Policy game, which teaches kids about how to, basically how to allocate resources to get results in an imaginary country, is they get better with practice, much better with practice. Is that third space going designed so that they can actually practice and say, oh, we got thrown out of the country in 4 moves. What if we try this? We won't get thrown out of the country until we've made 6 moves, and then, 4 or 5 iterations in, they can go, they can go all 12 moves, and they don't get thrown out of the country.
Yeah, so one of the things we're working on is, and I just have to get some funding. A guy named Dave Finnegan, he's in Australia, and he designed something called the Best Music Festival Ever. And it's basically a systems thinking game that's physical on a big table, and everybody participates, and they look at how to solve problems within complex systems. We would like to build something like that could actually be portable, because this is obviously not portable, and we have to figure out how do you take these ideas and insert them into a lot of different kinds of learning environments. Obviously, we're not there yet, but this was what we were doing for this particular venue, which the city was renovating for us. But we have a lot. This is just the very beginning, and as I kind of alluded to, we see this as a research platform to the extent that these kinds of experiences can be because it's a tabula rasa when you turn off the projectors. You could put anything you want on there, and we could use it for lots of different kinds of really deep understanding, learning that we haven't really talked about yet. And then thinking about how do you either make that portable, or how do you create extensions or curriculum material. I mean, there are all these different pieces that could either be a precursor or add-ons, or be completely independent, that we're sort of exploring now. It's all a matter of how much money you have to develop them. It's a start.
All right, it's 11. We should take a break. Thanks, Steve.